Space heaters need friends too. Let's try pushing a little harder. That is pretty hot. Hi everyone, Dave here. Today on my workbench I have the Vever 3500 watt pure sine wave inverter. This affordable around $200 inverter should be able to run my miter saw in my solar workshop. Note that I don't receive commissions for the sales of this inverter and I did not get paid to make this video. I'm just going to review the inverter as is out of the box and it either works or it doesn't. And now for the first test, I'll need my hammer. Oh wait, no, it's not that kind of channel. And I even took the time to look underneath. Now the included cables are a bit thin for 400 amps at 12 volts, but they will get you up and running, and I do recommend you upgrade them later. On the other hand, I totally get that inverter companies cannot spend but so much money on copper, and I don't know what gauge these are. It does have the manufacturer's name, but I can't see any particular information that is going to be helpful. That having been said, they look like nicely made cables, and I don't really have a problem with them at all. Just out of curiosity, I cut the cable end open, and it is crimped, it's not soldered. There looks to be a decent amount of copper there, and I did verify it's actual copper. The inverter comes with 8 50 amp 12 volt automotive fuses, so I do not expect this inverter to be able to handle much more than 400 amps, if at all. So much for the 7,000 watt surge that most people would assume an inverter like this should be capable of. And I'm going to hook it up with some quad 0 gauge cables and an A&L fuse. Will it survive my test? Well, I guess we'll see. Well, I'm certainly not obsessed with space heaters or anything like that. You can never have enough space heaters. Now you might be thinking, why pick a space heater as my first test? Well, the answer is this heater has a heating element which is actually more like a light bulb. When it first turns on, it draws a huge surge. Some space heaters will actually appear as an inductive load to the inverter when they're first switched on. And the Harbor Freight parabolic heater is one of those heaters. And that's why I've included it in my test. And here's a look at the bench test setup. I have 1400 to 1600 amp hours of lithium iron phosphate batteries. You can't see all of them, some of them are hidden away. I also have 0000 gauge cables connecting the input. These cables are pretty good for this size of inverter, and they minimize the voltage drop during the test. I do try to help beginners whenever I can, and I want to make something really clear. If you're willing to spend a few bucks on better quality, thicker cables with lower resistance, your inverter won't work as hard. It's the current or the amps that makes the inverter work hard. It taxes the inverter and causes it to generate more heat and become less efficient. If you can even get the voltage a half a volt higher because you use thicker cable, then the inverter will be a little bit more efficient and it won't work as hard. Lots of beginners don't understand this and they get away with cheap cables and they wonder why their inverter browns out on a heavy load or when starting a surge. The first thing you look at, it's your cables. It's all about connections. I have not one, but 2 DC clamp meters on the input cables to measure the current flowing. I also have a thermocouple set up to measure the temperature of the air coming out the back of the inverter, as well as the internal temperature of the electronics inside. To make it easier to do my testing, I have attached a power strip with a switch on it. Let's do a quick test using the Harbor Freight space heater. The inverter has an interesting looking display that shows the input and output voltage and some other information, which I think is pretty neat. Let's see what this does when I turn on the space heater on low. And it comes right on, about 500 watts. Now you didn't expect me to be easy on this inverter, did you? What I've done is I've plugged in my 10 gauge extension cord, and that's about 50 feet. It goes over here, does a U-turn, comes out here, and it goes all the way into the next room. And it ends up right there. And into that cable, I'm going to plug my miter saw, which is able to dim lights and pop breakers. My workshop, which I call the solar workshop, is off the electrical grid, and I cannot run this saw because I don't have a big enough inverter. And that's why I accepted this inverter. But the question is, can this 3500 watt Vever inverter run that saw? Well, let's find out. Now, because this is a safety-oriented channel, what I've done is I've taken some tape and I've taped the trigger down on my miter saw. I can just flip that red button there and the saw will come on. It's extremely loud and it blows sawdust absolutely everywhere. Okay, looks like it ran the saw, so that's good. Internal temperature has crept up to 65 degrees. I don't hear the fan has not turned on. So I guess this inverter is prioritizing peace and quiet and it doesn't turn the fan on except under certain conditions. Well, that's okay as long as it doesn't overheat. It looks like this inverter will be able to handle my miter saw, which is fantastic. But let's make it work a little harder than that. I've got the space heater on 900 watts. The display actually says 1020 watts, but that's no surprise at all. Let's go ahead and turn on the saw while it's running a 1000-watt load and see what happens. Internally, the inverter has started to warm up a little bit at 68 degrees, and that's to be expected. Yet so far the fan has not turned on. The space heater is running at 1000 watts. Let's go ahead and turn the saw on and see what happens. The display showed about 2,227 watts at some point when that saw turned on. That's a pretty good load, but let's try pushing a little harder. Okay, let's see if my clamp meters can catch the surge. I seriously doubt it, but let's give it a try. We're running 2 space heaters for about 980 watts. The saw is plugged in. Let's give it a try. Okay, the approximate surge in that test was 3,354 watts. Now I just want to make it plain that this oscilloscope here is having difficulty for some reason reading the output. I'm not sure what went wrong, but I just left it connected because, well, it's here. As you can see, here's the proper output. This oscilloscope is able to read it just fine. And there it is running at about 960 watts. Still looking pretty good. Alright, let's try turning on the saw while it's under a 900 watt load, and let's look at the oscilloscope output. Let's turn this one up to high. That one's really cranking. That heater is still on as well. 1,690 watts of power. Pardon the fan noise, it's actually caused by my charge controller, not the inverter. The inverter has still not turned its fan on, not even once. It's 84 degrees internally. At about 1,700 to 1,800 watts, this inverter struggles to maintain a clean sine wave output when starting an inductive load such as a miter saw. Now for me that's not an issue because I have this inverter here, which is a low frequency inverter, and I use that for running sensitive loads such as my desktop computer or anything else that I want to run that's sensitive. When it's just running a standard resistive load, the output is quite clean. There's nothing wrong with it at all. The inverter is now running at 2,181 watts. Space heaters need friends too. That one is running on high, that's running on high, and that's running on low. Now I can place the inverter under a bigger load and try to run the saw. The inverter's fan has turned back on. My battery voltage has dropped to about 13 volts. I'm getting about 350 watts in from the solar right now. Now let's turn the saw on and see what happens. Well, it ran the saw just fine, which is impressive, so I'll give it that. Let's see if I can detect the surge while running that saw. And of course my meter is limited in the type of surge it can measure, but I'm doing what I can with what I have. I do not have fast equipment that can measure the split-second surges that these inverters generate, but it's going past 3,500 watts, and that's pretty good. Now all 3 space heaters are on high, so let's see how many watts that's consuming. The display indicates 3,349 watts, approximately 91 degrees internally on the inverter, so it's starting to warm up a bit more. Now I'm going to do a long-term test where I just heat this inverter up for several hours, and then I'm going to do another surge test, and I'll explain why I do that later. Here you can see the cables going into the inverter are quite hot, or at least they're warming up. The entire body of the inverter has warmed up. The power cables have warmed up. You can see how power cables in fact function like sort of a heater. The ANL fuse is heating up, the cables are heating up, and that's to be expected. And here's a look inside the inverter. You can see the components in there are getting pretty warm. Maximum is 99 Celsius, and that is pretty hot. Yeah, I must say the components on the inside are getting a little too hot for my taste. 102 Celsius, 2980 watts. And the fan on the inverter has definitely come on. Now for a real surge test. The inverter is currently running at 3 kilowatts, so 3000 watts. And I'm going to turn on the saw. Now this is a very severe test, and the reason why I let this inverter heat up before the surge test is completed is because power MOSFETs are most vulnerable to failure and destruction or damage when the inverter is hot. Now that this inverter is heated up, let's do the surge test. So I'm running 3000 watts, or just under 3000 watts, and I'm going to turn on the saw. Now truthfully, I do expect this inverter to overload and shut off, but let's give it a chance. So the inverter could not start the load because it was surging to over 4800 watts. So this inverter does not have a 7000 watt surge. It's common among beginners to think that you can just double the 3500 watts and that's your surge. Nothing could be farther from the truth. This inverter has approximately a 20% surge. With a 1640 watt load, this inverter is able to start my miter saw, which is quite impressive in and of itself. Under a 1893 watt load, this inverter was able to start my miter saw at the same time, so that's good. Under a 2214 watt load, this inverter was able to start the miter saw as well. Under a load of 2547 watts, this inverter could not start my miter saw. I repeatedly overloaded this inverter, and so far I haven't fried it. It has pretty good overload protection built in, and that's a good thing. This inverter seems to work pretty good. It's relatively affordable. It can start a pretty large load, including inductive loads with a surge, and it's able to run multiple loads simultaneously while starting an inductive load with a surge. The inverter appears to be of good enough quality, it gets the job done, and I don't really have a problem with it. The included cables are about the best you can expect in this price range, and I do highly recommend upgrading them, but keep the original cables for other purposes. I'm not trying to sell you an inverter. I don't get paid for this video, nor do I get commissions if you buy one. However, there is a link and discount code which I placed in the description for you. If you like this video and you want to support my work, please consider subscribing, give it a thumbs up, and leave a comment if you have time. Thanks for watching, folks, and I hope to see you next time.